On the 14th of July, 2017, the United States Navy commissioned its most powerful warship in the history of the American fleet, a vessel that had taken 11 years to design and build. That had cost $13.3 billion, more than any warship ever constructed. That incorporated technology so new and so ambitious that critics argued it would never work reliably, and that represented America's definitive answer to a question: what is the ultimate expression of maritime military power? The USS Gerald R. Ford, CVN-78 in the Navy's hull classification system, is the answer. An aircraft carrier of such capability that its combat power exceeds that of entire air forces. A vessel that can project American military power anywhere on Earth within days. That can sustain combat operations continuously for months. It carries enough aviation fuel, weapons, and supplies to conduct thousands of aircraft sorties before requiring resupply. And that does all of this powered by 2 nuclear reactors, generating electricity without fuel oil, without exhaust, for a service life measured in decades. The Gerald Ford is not simply a larger version of the Nimitz class. It is a fundamentally different approach to aircraft carrier design. Steam catapults replaced by electromagnetic launchers, hydraulic arresting gear replaced by electromagnetic systems, older mechanical systems replaced by automation that reduces the crew required by approximately 500 people compared to a Nimitz-class carrier. These changes were intended to produce a carrier that could launch and recover more aircraft per day than any previous carrier, and that could accommodate the next generation of aircraft, including unmanned systems, that the Navy anticipates operating in coming decades. The lessons learned from CVN-78 are being applied to its successors, John F. Kennedy and Enterprise, in ways that will define carrier aviation. But before we get into the technology, we need to understand the strategic logic that justifies $13 billion for a single warship. The United States could build thousands of tanks, hundreds of destroyers, or dozens of submarines for the cost of one Gerald Ford. Why does the Navy believe that one aircraft carrier is worth more than all of those alternatives? The answer requires understanding what aircraft carriers actually do, not as military hardware, but as instruments of national power. It is measured in the ability to shape events on the other side of the world without firing a shot. An aircraft carrier does not operate alone. It operates as the center of a carrier strike group, a formation of ships. This formation includes guided missile destroyers, guided missile cruisers, attack submarines, and support vessels, all organized around the carrier and its air wing. The carrier provides the air power. The destroyers and cruisers provide surface and air defense. The submarines provide underwater protection. The support vessels provide fuel, ammunition, and supplies. Together, they form the most capable mobile military force in history. The Gerald Ford can carry approximately 75 aircraft, including F/A-18 Super Hornet strike fighters and EA-18G Growler electronic warfare aircraft. It also carries E-2D Advanced Hawkeye airborne early warning aircraft, MH-60 helicopters, and C-2A Greyhound carrier onboard delivery aircraft. In future configurations, the air wing will include F-35C Lightning II stealth fighters and potentially unmanned aerial systems. This collection of aircraft gives the group the ability to conduct air superiority missions and strike missions against land targets simultaneously. The strategic utility of this capability is not primarily about winning wars. It is about deterrence, the prevention of conflicts. When a carrier group moves into a region, potential adversaries know the United States can project overwhelming air power immediately. This knowledge shapes their calculations. It constrains their options and makes aggressive actions less attractive because the cost is too high. The Gerald Ford can be anywhere in the world within days. It requires no permission to operate in international waters. It carries its own airport, fuel supply, weapons, and its own crew of approximately 5,000 people. It is sovereign American territory, 332 meters long, moving at 30 knots through the oceans of the world. This allows the president to respond to any crisis without the delays and political complications of basing negotiations or host nation agreements. This is the strategic argument for $13 billion. It provides a quality of strategic presence that land-based alternatives cannot replicate. The United States has operated carriers continuously since World War II. The strategic logic has been validated by 6 decades of experience. The Gerald Ford is the current expression of that logic, pushed to the frontier of what technology and naval engineering can achieve. These technology choices, both successful and challenging, are the engineering story of the ship. For 60 years, United States aircraft carriers launched their aircraft using steam catapults. These systems used high-pressure steam from the ship's boilers to accelerate a shuttle along a track in the flight deck. They drove aircraft from rest to flying speed in 2 seconds. They were reliable, proven, and understood for 6 decades. However, steam catapults had significant disadvantages. They required enormous quantities of high-pressure steam and massive distribution piping. The energy was difficult to precisely control. Launch settings were fixed before each shot and couldn't be adjusted during the stroke. This imprecision created stress on lighter aircraft airframes, while heavier aircraft risked receiving insufficient energy for a safe launch. The electromagnetic aircraft launch system, EMALS, replaces steam with electricity, using a linear induction motor. This motor uses electromagnetic force to accelerate the shuttle. Energy is stored in large flywheel systems that discharge during launch. EMALS precisely controls the force in real time, providing the exact energy needed for each specific aircraft weight. The system is more compact, freeing up below-deck space for weapon storage, fuel, and better crew accommodation. EMALS also enables higher launch rates. It resets in 45 seconds, compared to 2 minutes for steam systems. The goal is 160 sorties per day in surge operations, substantially higher than the 140 sorties of Nimitz-class carriers. But development was difficult. The linear induction motor and power electronics required development beyond the state-of-the-art. The Advanced Arresting Gear, or AAG, presented similar challenges, replacing the traditional hydraulic system used since the 50s. AAG uses an electromagnetic energy absorption system. It converts the aircraft's kinetic energy to electrical energy during the stroke. This system provides smooth, optimized deceleration for each aircraft type. However, early development was plagued by reliability failures. Combining mechanical components with high-power electrical systems in a harsh marine environment proved more challenging than anticipated. The experience taught lessons about risk management of novel technology that are now being applied to future carriers. The USS Gerald R. Ford is powered by 2 A-1B nuclear reactors, a new reactor design developed specifically for the Gerald Ford class. The A-1B reactors are more powerful than the A-4W reactors used in the Nimitz class, providing approximately 25% more electrical generating capacity. This capacity makes the EALS and AAG systems possible. Both require large, instantaneous electrical power demands that older reactors could not have supported. Nuclear propulsion provides strategic advantages. A nuclear-powered carrier has essentially unlimited range. It can operate for 25 years before requiring reactor refueling. The carrier can steam at full speed, approximately 30 knots, indefinitely, without the range constraints that would limit a conventionally powered vessel. This speed and endurance advantage gives the Gerald Ford the ability to respond to crises faster and to sustain operations longer than any alternative. The Gerald Ford carries approximately 5,000 personnel. These people must be housed, fed, and provided with medical care and recreation. The ship has berthing spaces ranging from spacious officer staterooms to the bunk beds in enlisted berthing areas familiar to all who have served. The ship's mess facilities can serve thousands of meals per day. Medical facilities include an operating room, dental facilities, and mass casualty capability. The weapons carried represent a concentration of destructive capability that has no parallel in history, featuring precision-guided munitions and long-range missiles. Guided missile destroyers and cruisers in the strike group carry hundreds of Tomahawk missiles, while attack submarines provide additional underwater lethality. The Gerald Ford's flight deck, a 332-meter runway, is the defining feature of the ship's external appearance and its operational concept. The flight deck is an extraordinarily dangerous working environment. Aircraft taking off with afterburners create noise exceeding 150 decibels. The flight deck crew, the Airedales, identified by the color of their jerseys, operate under protocols designed to manage these extraordinary hazards. The island superstructure houses the bridge and the pry-fly control, from which the air boss controls all aircraft activity near the ship. The 2022 deployment demonstrated that the ship's systems were capable of delivering the operational performance the Navy had designed them to achieve. The crew demonstrated that reduced manning levels enabled by the Ford's design were operationally achievable, marking a new era of naval power. The USS Gerald R. Ford is the first of a class that will eventually include at least 3 ships: CVN-78 Gerald Ford, CVN-79 John F. Kennedy, and CVN-80 Enterprise. Each successive ship in the class benefits from the lessons learned on its predecessor. CVN-79 incorporates refinements to the emails and AAG systems based on operational experience with CVN-78. CVN-80 will incorporate further improvements. The class will eventually replace the 12 Nimitz-class carriers as they reach the end of their service lives, a process extending over decades. The Gerald Ford-class carriers will operate the F-35C stealth fighter as a significant component of their air wings, replacing the FA-18 Super Hornets. The F-35C's stealth and data fusion capabilities will extend the wing's ability to operate in contested environments against advanced air defense systems. The EMALS system is designed to launch the full weight range of current and anticipated future aircraft, including unmanned aerial systems. The threats the Gerald Ford class will face during its service life, which extends into the 2060s, are different from the Nimitz era. Investments in integrated defense, electromagnetic launch, and automation reflect that the carrier of the 2050s will need capabilities we couldn't have imagined. The $13 billion cost of the Gerald Ford is an extraordinary expenditure, but the strategic capability it provides is a different kind of calculation. In 8 decades, no adversary has successfully struck a U.S. carrier in combat. The deterrent effect of that record is genuinely real. The cost must be evaluated against the conflicts it deters, the crises it diffuses, and the strategic options it preserves in a world of power. The engineering answer is the USS Gerald R. Ford, a vessel that can launch 160 sorties per day using electromagnetic catapults. It carries 5,000 people and 75 aircraft. Powered by nuclear reactors for 25 years without refueling, it can operate at 30 knots indefinitely. Stand on the flight deck and watch an FA-18 Super Hornet launch, accelerating from rest to flying speed in 2 seconds. Then watch a second aircraft follow 20 seconds later, then a third. The technology works. The ship works. The most expensive warship is doing its job. Next, we move from America's newest carrier to its most proven, the USS Nimitz, and the class that carries its name. 12 ships, 4 decades of continuous service, the backbone of American naval power for an entire generation. The Nimitz story is about the engineering discipline of building a complex system that works reliably for 40 years in demanding environments. The numbers are extraordinary. The operational record is even more so, and we are just getting started.